Hello, this is Mrs. Boots, and we're going to work through the practice problems for the graphing radicals lesson. Remember, there are two types of radicals that we graph in this lesson, the square root and the cube root. So the first thing we need to identify is which kind is it. In problem number 1, I have a square root. Remember, the square root has a shape where it goes up and to the right. It doesn't go to the left at all. This is the one where it can't equal 0. So what's my transformation? Well, the 3 underneath the radical tells me it's going to the right 3. The 4 is going up. So we're going right 3 and up 4. So from 0, 0, I go right 3 and up 4. This is my new starting point for my curve. Now I could, if I wanted to, draw my table and add 3 to x and add 4 to the y values. I would get 3, 4, 4, 5, and 7, 6. Remember, this is from our parent function that we're doing this. If you don't like that method, you can just go up 1 over 4, up 2, because remember the square root of 4 is 2. So you're either memorizing the pattern of the parent function or you do the table, one or the other. Now let's do domain and range. The domain. I started at what x value? 3. I do include the 3 because it's on the curve, and it's going to positive infinity. Now the y value. The lowest it goes is 4. So my range starts at 4 and goes to positive infinity. Number 2. What kind of radical do I have? Well, the 3 out front indicates that it's a cube root. Remember, the cube root goes all the way across the graph, infinities to infinities. But let's look at the transformation. What does the 1 under the radical tell us? It's moving left 1. The 3 out front just indicates which root it is. It's not a stretch or compression. If we wanted to, we could do a table. The y values stay the same, and with the x values we would subtract 1. My table would be -9, -2, -2, -1, -1, 0, 0, 1, and 7, 2. So we went left 1. And we go up 1 to the right, down 1 to the left. 7 is almost off my graph. And then over here, the -9 is way off. But that's okay. This is our cube root function. Let's look at domain and range. We already talked about a little bit. It goes from negative infinity to positive infinity. For the domain, what about the range? Yes, the range also goes from negative infinity to positive infinity. Number 3, what kind of function is it? This is a square root. So we know it's going to go up and to the right. Well, let's look at the transformations. The negative out front tells me it's reflected. The 5 inside tells me it's moving to the right. And the 3 at the end is moving down. So I go right 5 and down 3. That would be my starting point. If I wanted to do the table, I would do an x plus 5. Remember, it's opposite because it's lying to you. The negative would be in front of the y, and then I would subtract 3. So my table would be 5, 6, 9 for my x's, and negative 3, negative 4, negative 5 for my y's. Let's put those on the graph. Connect the dots to make your curve. Now, what's the domain and range? My domain starts at 5. The 5 is included, and I'm going to positive infinity. My range, the highest it goes is negative 3, but it's going to negative infinity because it goes down. Remember, you have to put negative infinity first. Then we would put the negative 3 with a square bracket. Number 4. What kind of radical do I have? This is a cube root. Okay, so the cube roots are the one that looks like the S shape, just like the cubes. Let's look at the transformation. The 6 at the end is negative, so that tells us we're going down. So I go down 6. If I were to put it in a table, my x's would stay the same. And for my y's, I would subtract 6. My new table would be negative 8, negative 8, negative 1, negative 7, 0, negative 6, 1, negative 5, and 8, negative 4. So I don't go all the way out to 8, but we can do the ones real close. So we have our 1s, and then we go out to the edges. Remember, it always goes up on the right and down on the left. That helps with the shape. Now let's do domain and range. Super easy for the cube root because it keeps going in both directions. There's no stops or breaks. So we go from negative infinity to positive infinity. Number 5. What kind of radical is it? It's a square root. Okay, so I know square roots go up and to the right. Let's figure out our transformations. The 2/3 out front is actually a compression. I know I'm going to have to multiply by 2/3. The one on the inside is being subtracted, but we do the opposite, remember? So it's going to go to the right one. So I go to the right one. This is my new starting point. We could plug values in. We could take our original parent function, and with the x's we would do what? Yes, we would add 1, do the opposite, and with the y's we would multiply them by 2/3. It gets a little crazy, but that's exactly how you do it. So I have 1, well 0 times 2/3 is 0. 2, and the 1 times 2/3 would be just 2/3. A 5 instead of 4. And this would be 4/3. It gets a little tricky to graph, but that's okay. So at 2, I go up 2/3. And at 5, I'm going to go up 4/3, which is 1 1/3. So it's just above the 1. So my radical is a little bit squashed. Not as tall because we compressed it. Now let's do our domain and range. Domain. Where does it start? It starts at 1. And it goes to positive infinity. My range starts where? It starts at 0. And I'm also going to positive infinity. Number 6. What kind of function is it? The 3 out in front of the radical tells me that this is a cube root. So we know it's going to have the S shape. What are my transformations? Inside I have a 5. The 5 moves it to the left because we do the opposite. On the outside we have a 7 that's subtracted. That tells us we moved down. So we move left 5 and down 7. This is my new starting point. This is the 0, 0. I'm going to go ahead and label. Okay, if I wanted to use the table to find the points, remember we would change the sign inside, so I would have x minus 5, and I would take all my parent function y values and subtract 7. So the ordered pairs would look like this. Negative 13, negative 9, negative 6, negative 8, negative 5, negative 7, negative 4, negative 6, and 3, negative 5. So we would put those on our graph. And you notice one of them is way off the graph, but that's okay. And we have our S shape. Now let's look at the domain and range. I know, it's a cube root. And you're thinking, why are we still doing this? Because every now and then I have students who mix up cube roots and square roots. And instead of going from infinity to infinity, they do the positive half only. Number 7. What kind of function do we have? Well, we have a square root. Oh, there's something different. We have an inequality on this one. Well, that's okay. We're just going to graph the line the same way, and then we'll figure out where to shade it. So what does the negative do? Reflect. The 1 inside lies to us, so instead of moving to the left, like the sign thinks, it's going to move to the right. The 7 outside moves up. So I go right 1 and up 7. That's the beginning of my curve. But my curve reflects, so instead of going up and to the right, I have to go down. Now my inequality plays a part. I have a less than symbol. So is it shaded? Is it dashed or solid? Yeah, this one's going to be a dashed line. So I come in here and I'm just going to make some dashes to fill in my line. Hopefully yours turned out prettier. And now which way do we shade? Yes, it's a less than, so we shade down. Okay. Remember, with the square roots, you have to stop where the function stops. So when we shade down, we only shade directly underneath the function. Anytime we do a shaded, we have to check a point. We want to check an easy point, right? So what should we check? I'm thinking right in there. Something that's got a 0 as part of the point, because that simplifies my answers. So I'm going with 2, 0. Okay, plug it in. So y is 0 less than negative square root of 2 minus 1 plus 7. Well, the square root of 2 minus 1 is the square root of 1. So I have 0 less than negative 1 plus 7. That means 0 is less than 6. Is that a true statement? Yes. So we shaded in the correct spot. Good job. Number 8. Again, an inequality. What kind of radical do I have? I have a cube root, so I know it's going to be an S shape. But let's look at our transformations first. What does the -2 do? It does two things. It's going to reflect it because it's negative, and it's going to stretch it. Remember, by stretching it, we're making it taller. Okay, the 7 inside moves it to the left, and the 5 at the end is going to move it up. So I go 7 to the left, and then up 5. That is my new starting point. Now we get a little tricky. Remember, we used to go over 1 and up 1? Well, now we have to go over 1 and down, but we're going down 2 because we multiplied by 2. Same thing in reverse on the other side. We're going to go over 1 and up 2. Now when we go out, we go out 8, and instead of going down 2, we go down 4. So my S shape is running into my words. Comes across like that. Is it supposed to be solid? I should have checked. Look at the inequality symbol. It's a greater than equal to. So it is a solid line. That's good. Which way do we shade? We're going to shade up because it's a greater than. So I would shade everywhere above my cube root. Everywhere. Left, right, across, all the way above. Now we need to pick a point to check. Remember, you want a point in the shaded region. If you go directly above a dot, usually your square root works out. So you get perfect squares. So I'm going to pick this dot because it's at a 1, and I'm just going to go up to this point. What is that point? That's 1, 3. So I'm going to check 1, 3. Plug that into the equation. So y is 3, and we want to know if it's greater than or equal to -2 times the cube root of 1 plus 7 plus 5. 1 plus 7 is 8, and the cube root of 8 is 2. 2 times -2 is -4. So -4 plus 5. So is 3 greater than or equal to 1? Yes. That means we shaded in the correct region. Number 9. What kind of function is it? This is a square root, so we know it's going to go up and to the right. Okay. Now, let's look at our transformations. The 3 out front is a stretch. The 2 underneath moves it which way? Left. Remember, he's lying to us. It goes the opposite. The 4 goes down. So, I'm going to go left 2 to -2 and down 4. You can still do the table if that makes it easier for you. It doesn't matter to me which method you choose. That's my starting point. Now see that stretch? Instead of going over 1 and up 1, I'm going to go over 1 and up 3. You got it. Over 4, I would normally go up 2, but instead of going up 2, I'm going to go up 6, because 2 times 3 is 6. Now what kind of line do I draw? We're going to draw a dashed line. It's dashed because there's no equal sign underneath that inequality symbol. So we draw a beautiful dashed line. Which way do we shade? We are going to shade up. We shade up because it is a greater than. So directly above my curve, I'm going to shade up. Remember, we cannot go past the starting point. We have to go only above the curve. So we've got our shaded region. We should check that. So I'm going to pick a point directly above another point to check. We can pick this point right in here. I could have picked the one below it with the 0. Would you prefer that? Let's do that. It doesn't matter which point as long as we pick one that's in the shaded region. So we're going to check. What point is that? That's -1, 0. Okay. Y is 0. So I have 0 greater than 3 times the square root of -1 plus 2 minus 4. -1 plus 2 is 1. Square root of 1 is 1. 1 times 3 is 3. 3 minus 4. So is 0 greater than -1? Yes, this checks. That means we shaded in the correct region. Number 10. What kind of radical do I have? I have a cube root. That's awesome. I know it's going to go all the way across in an S shape. What's my transformation? I only have one transformation, and that's the 2 on the outside. Because it's negative, we know it's going down. So I go down 2 and put my reference dot. There's no stretch or compress. So you go up 1 and down 1. Over 8, up 2, over 8, up 2. Now what kind of line am I going to draw? Well, it's got the inequality symbol with an equal sign. So I'm going to draw a solid line. So I connect my dots. Beautiful. Now, what kind of shading? Well, since it's a less than symbol, we're going to shade down. So underneath that curve, all the way across the graph, we're going to shade down. Now we get to pick a point to check. We want to always check our shading. Which point should we pick? Well, I'm just going to go on the y-axis because then I can keep a 0 in there. What's that point? That would be 0, -5. Okay, we're going to check that. So I have -5 as my y, less than equal to the cube root of 0 minus 2. Well, the cube root of 0 is 0. So I just have -5 less than equal to -2. Is that a true statement? Yes, -5 is less than -2. It's lower on the y-axis. So we shaded in the correct region. Number 11. What kind of radical do I have? I have a square root. So I know it's going to go to the right. What's the transformation? The negative in front tells me it's going to reflect. The half tells me it's going to compress. What does the 1 underneath the square root tell us? It tells us it's moving to the left. So I go left 1. That's my starting point. Instead of going up, I'm going to go down. And instead of going up 1, I'm going down a half. I go over 4, I would go down 2, but I have to divide it by 2, so it becomes 1. And then with 9, we would go down 2, but instead it's going to be 1.5. Actually, it would be 3, but now it's 1.5. Okay, what kind of line do we draw? Yes, it's going to be a solid line. How do we know that? Because of the equal to under the inequality. So I'm going to connect all those together to make my curve. Now what kind of shading do we have? It's a greater than, and greater than means we shade up. So I'm going to shade directly above the curve. Remember, do not cross the starting point. You can only shade directly above. Now we're ready to check. The easiest points to check are right above points that are already on my graph. So I could pick a point on the y-axis, or I could pick a point on the x-axis. Either one. I'm going to use the point on the x-axis. That would be the point 3, 0. Okay, so let's plug it in. Y is 0, greater than or equal to -1/2 times the square root of 3 plus 1. What is 3 plus 1? 4. What's the square root of 4? 2. Okay, let's go that far. So I have -1/2 times 2. Well, 2 divided by 2 is 1, and now it's negative. So 0 is greater than or equal to -1. Is that a true statement? Yes. So we shaded in the correct region. Number 12. We have what kind of root? Cube root. What's the transformation? The negative out front tells me it will reflect. The 5 tells me it's moving to the left because of the sign. The 3 is positive, so it's going to move up. So we go up 3 and left 5. This is my new starting point. Remember, it's a cube root, so that starting point's kind of in the middle. Now it's negative, so instead of moving up and to the right, we're going to go down and to the right. And then up and to the left. Let's get one more point on there. Okay, we draw our curve. Did I draw that right? Let's look at the inequality symbol. No, it's not solid. It's dashed. So I need to go back and make it dashed. Well, that's not a problem. We'll just put some dash marks over top so that we know it's dashed. If you don't like that, you could go in and erase. So anytime you make a mistake, the mistake is easy to fix. Now, which way do we shade? Because it's greater than, we're going to shade going up. Okay, so above my curve, I shade. All above the curve. Remember, the cube roots don't have any limits where you have to stop your shading. But we still need to check. What point do we want to check? Let's pick a point that's directly above another point in our shaded region. I'm going to pick the point 3, 3. Does that work? Yes. Okay. So 3 is the y. 3 greater than negative. I want the cube root of 3 plus 5. And then we add 3's. That's a lot of 3's. That's okay. Now let's look at it. 3 is greater than negative. 3 plus 5 is 8. Cube root of 8 is 2. Negative 2 plus 3 is 1. 3 is greater than 1. Is that true? Yes. That means we shaded in the correct location.